Okay, before I get started, are there any questions, concerns? I know with that one, with the exception of that gentleman, everybody has been able to get GitLab hooked up. So that's great. That was one of the most challenging things, and getting over that hump and getting connected with Git and GitLab is a real uh, significant advantage when you're doing things like developing code. I mean, that's what it was uh, designed for. It's the latest in a long line of version control systems that literally go back decades. They kept refining it. This one we're using, Git, happens to have been written by Linus Torvald, the gentleman behind Linux. Um, and so he just kind of reimagined the whole thing in really a brilliant way, and it's why it's the most popular open source, if not every kind of version control system. Um, the thing to keep in mind for that is that there are two different repositories now. There's one local on your computer, and there's one on GitLab, and that's by design. And so the thing is that I don't have access to your computers, but I do now have access to all of your GitLab repositories because you gave it to me when you designated me a developer. You have access to my GitLab repository. So if you haven't done already, you should clone mine. And and the thing, the potential confusion for that is that when you push your code to GitLab, it has to be to your repository. That is, by making you a reporter and not a developer, you can clone and pull from mine, but you can't push to it. By making me a developer on yours, you've given me permission to push to yours. And the reason for that is that if we're in the middle of an assignment and, let's say it's, I don't know, the weekend or something, and you send up a help message or something like that, something is you're sort of banging your head on something. And, and it's something that I feel that I can just sort of easily fix and correct. What I can do is I can clone what's on your GitLab, and I can fix it, and then I can push it back up, and so that you can pull it back down and see what's being fixed. Again, it's not my job to write your code for you. And however, because my goal in this class is for you to have Java in your toolkit, there are times when you're learning this kind of stuff, you just get stuck on something that really has nothing to do with what the objectives of the programming assignment is. It's just some silly thing. And, and so if I can help you get over that hump, then that's to everybody's benefit. Now I'm not gonna, if it has to do with something which is essential to the objective of the assignment, I'm not gonna do that for you. But again, there are a lot of moving parts on this, and it's and if you get stuck on something that again has nothing to do with what the learning objectives of the assignment are, then I'm more than happy to kind of just get you over that hump. And that's why I have developer access, because I can just sort of fit and I can fix it, push it, and then you can get that done. Again, that's just for these kind of issues that kind of come up around the edges, and unfortunately there are a lot of those. Okay, so if there are no questions, I noticed that I did not get through all of yesterday's slides. There are some that I'm going to skip over a little bit because it was in the reading and is fairly straightforward, but there is some very important concepts that I do want to make sure that I cover. And so we are going to start there. So this is from yesterday's just close that out. Okay, so this is from yesterday's, and starting around slide 7. Okay, this idea of encapsulation is a very important one. And the idea is that every object protects its inner state from, quote, the outside. And what is the outside? The outside is anything outside of that object. And so what it does is it hides its member variables, these instance variables, from any other object. And it only allows the access that the design allows. So for example, in the light class that we had yesterday, it allowed any other object to see whether the light was on and to see what the level of that was. But it did not allow any object outside of the light to set that value directly. The only way that it could change the value was on by invoking the method turn on. And the only way it could make it go false is to invoke the method turn off. Likewise, the only way it could change the level is to invoke either dim or brighten. Those were the only two methods. So the idea is that in designing the class, these methods are what protect the data. So in other words, it prevents somebody from just reaching into the object and changing the value willy-nilly. And that's, okay, why is that important? Because programmers realized after a while that variables that were just sort of getting changed in strange ways. So this way, if this light class and instances of this light object are part of some larger program, and all of a sudden the on instance variable gets changed somehow, there are only two ways that could happen. The only two ways are through that method, through the two methods, turn on and turn off. So in other words, in this case, there are 2 points of failure. The optimum number of places is actually 1, but in this case, 2 is not bad. So in a large program, if that value is being changed, the only way it could be changed is if somebody is invoking one of those 2 methods. And so you can trace that and find out what the problem is. The way that Java implements this is by what are called access specifiers. Again, the name is not so important, but these names are. So we've seen private. You notice that the instance variables for light were defined to be private, and all instance variables must be defined to be private, at least for this quarter. What private means is that no other object can go in and change that value. But within the class, of course, you can. The other modifier we've seen is public. We've seen it in several places. We actually saw it in the hello world, where the class was defined to be public, and the main method was also defined to be public. Okay, what public means is that anybody can sort of use that thing. So for a method, usually the methods are going to be public because you write these methods in order for other objects to invoke them. And so by making them public, you say any other object can invoke this method. Okay, so that now there are some that we are not going to use this quarter, and some that, again, that should never be used. Okay, this one protected, again, protected is something that we will encounter for those of you who take the discrete event simulation course. That is something which becomes useful in that context. But in this quarter, we won't use it. The other is, and this is kind of confusing, there's something called package level access, and that's when there's no modifier whatsoever, and that should never be used. That is, unfortunately, if you're coming from a loosely typed or a non-typed language like JavaScript, it's common to define your variables without any kind of modifier. So this is a very common thing to watch out for. because if you're not used to saying private for your variables, you're just sort of used to having no modifier. The other confusing thing is that when there are things called local variables that we'll get to in a bit, that don't have modifiers. So the modifiers apply to instance variables associated with classes, but within methods, there are local variables which do not have modifiers. So that can be a little confusing. Okay, so the idea, this reuse thing, it was a big deal when object-oriented programming first came out. But one example of that is the fact that we can instantiate multiple instances. So for that light object we can instantiate as many lights as we want. It could be 1, it could be 100, it could be 1,000 or 1,000,000. And so in each object, each of those objects has its own state. And so whether it's on or off, what level it's on, okay, each object has its own value for that. Furthermore, and we haven't seen an example of this yet, but we will next week sometime, I think, is that a class, you can contain an instance of another class. That's sometimes called composition. We're actually going to see a form of that called aggregation, but the names aren't important. I don't want you to worry about the names. That's just sort of fussing. Again, the objective here is for you to have Java in your toolkit so that you can use it when the time is appropriate. And again, for those of you who are taking the discrete event simulation course, that's going to be an immediate time where this is going to be useful. Now, here's one of the important concepts, and that is inheritance or subclassing. And so a class can extend the functionality of another class, and that's something that I like to call the programming virtue of laziness. So the idea is that if I can write a class that inherits all of the information from the superclass. Why would you do this? Well, because sometimes you want to add some additional variables or additional methods or customize it in some way. Now, remember that classes and types are more or less the same. So this is an important idea. The subclass is the same type as the superclass. Now, in other words, instances of the subclass can be assigned to a variable of the superclass type. We'll see an example of that.
Arnie, is this?
The reverse is not true. The superclass is not the same type as the subclass. So if I have a variable that I've defined to be the subclass, I cannot assign it to an instance of the superclass. And we'll see. Here's an example.
So, Arnie, is this the same as prototyping from JavaScript?
For purposes of Java, I think it would be most beneficial for you to put aside the concept of prototypes. It confuses things in this context. I really wish JavaScript had not done that. But yeah, so put aside the prototype idea for now.
It seems like a parent-child relationship. It's more similar.
It's exactly a parent-child relationship, or if I understand you correctly. In other words, okay, so this is another UML construct, and let's see what this means. Okay, so here's a class called shape, and it has two methods, draw and erase. Again, typically it would have a whole bunch of other stuff, but for purposes of this example, we're just going to focus on these two methods. So I define a class called shape, and shape has I define a method called draw and a method called erase. What that means is that every variable which has been defined to be a shape can invoke draw and erase, and the compiler will allow that. Now, what this says is, this says a circle is a shape, but has its own draw method. In other words, If you look at the three subclasses, so here's a square subclass and it has its draw method. And here's a triangle class, which is a shape. It has a draw method, but it also adds another method called flip. Okay, so now, I mean, why would you do this? Well, if you're drawing a circle, hopefully it'll look, well, better than that. If you're drawing a square, hopefully it'll look like that. And if you're drawing a triangle, it should look something like that. So what the draw method does is going to be different depending on whether you're a circle, a square, or a triangle. However, this is where the laziness kind of comes in. The erase method could be written in such a way that it just works the same regardless of how something was being drawn. So the erase method could be implemented up here. And because each of these classes, circle, square, and triangle, are subclasses of shape, they all have this erase method. So you can invoke it.
What would the draw in the shape object do? Like what code would have that the others didn't?
It probably wouldn't do anything. That's a great question. Probably it wouldn't do anything. It would just be kind of an empty method.
If there was code that was like universal to all of them, like drawing a canvas or something, is that something that you would put in a parent object?
Well, if you're talking in the context of a canvas, that would be more of an aggregation. In other words, a canvas would have a collection of many different shapes. And what the canvas would do, so the canvas, you think of an array. It probably would be a more, think of an array. So if I have a canvas, would be a completely separate object. And in that canvas, there would be, let's say, an array of these shapes. And when it was time for the canvas to draw itself, to display itself, what it would do is it would just go down that array and invoke draw on every one of the shapes. And the way that would work, because the canvas could define the type of its contents as simply a shape. It wouldn't have to know or care what the individual objects were, but it would, because the shape has the draw method, it knows that every shape would understand that draw method. So if it has a bunch of circles, squares, and triangles in this context, it would just kind of go buzz down and say, you draw yourself, draw yourself, draw yourself. And whether it was a circle, square, or triangle, it would invoke the appropriate draw. And I mean, presumably they would, each of these would have additional information. Say the canvas would probably have to say, well, draw yourself at this location and draw yourself, with this color and et cetera. Does that answer the question?
I think so, sir. I just need to see some code examples, I think.
Yeah, and again, we're going from the bottom up here. So I mean, it's good that you're kind of thinking in these terms, but I mean, it's to try to give an example of what you're describing, to kind of put this in that context would take a lot longer than we have for what we're after here. So just looking at some of the code here. So I can define, here I'm defining my shape is a type of shape. Okay, so this type concept is very important, and that's something which does not exist in non-typed languages. Okay, so I can instantiate a circle as a shape, because a circle is a shape. This works. And so because a shape understands draw, because the type of shape has this draw method, that works, okay? Now I can now take this variable and assign it to a triangle. So a triangle is a shape, and that would work. However, okay, now this is something that may cause some confusion. Notice triangle has a method called flip. And so if I have a triangle, there's no reason why I can't flip it. Why don't circle and square have a flip? Well, what does a circle look like if you flip it?
The same circle.
Same.
Yeah. Okay, so so shape does not have a method called flip. So this is not allowed, even though this variable actually is a triangle. Okay, so this is basically the compiler is like anal retentive in that it is very, very strict. It says you have declared this variable to be a shape, and shapes do not flip. So I'm not going to let you do that. Okay, so all right, now here I can define, here's a circle. I can define something to be a circle because a circle is a class and a class is a type. However, this is not allowed. In other words, I cannot assign an instance of shape to a circle. Okay?
Just a
Yeah.
quick question for the triangle where you're talking about flip. How would you call the flip function then?
Like this.
Or maybe I'm getting ahead of us.
Well, I mean, you call a function by using dot.
So it'd be triangle dot flip instead of my shape dot flip.
No, because I can't say triangle dot flip because triangle is a class, and these are instance methods.
I think you have to instantiate it with triangle, my triangle first, and then you can do
Yeah.
triangle flip.
Yeah, well,
Okay, that
yeah,
makes sense.
what he said was absolutely correct. In other words, if I want to flip something, I need to declare it as a triangle. And then that'll work. Let me show you some examples here. Let's see, where's my NetBeans here? Okay. Okay, so let's. I'm going to focus just on that. So let's. Okay, so here's my class shape. And now I'm going to commit a sin here. And the sin I'm committing is putting a print statement in an object. And I'm allowed to do that because I'm the instructor, but you're not. In other words, print statements should never be in objects. You'll hear me harangue about that more. But here, just for this example, I want to show you. Okay, so here's the shape class again. And what these print statements are just to show kind of what's happening. Now again, in your other languages, you may be used to having more than one stuff in a file. One of Java's rules is that there is only one class per file. So okay, so here's how I define, here's how I specify that triangle is a subclass of shape. That's how I implement a subclass. And now, oops, draw. Okay, so what's going to happen is if I invoke, oops, print. And actually, Java provides these things, you don't have to worry about it too much, but this is called an annotation, and that just indicates that what I'm doing is I'm overriding the draw method in the superclass. You don't have to worry about that now. We'll talk about that later. Okay, so here's the flip class. Okay, so we have the shape, and here's a triangle. All right, so now, my main class is always going to be separate. So let's put it here. Okay, and again, and this can be a little confusing. Notice our package is actually looks like a sub package of CS2173, but however, it doesn't find shape. Now here's the thing about red squigglies. This is the Java compiler will not let you run a program if there's no chance of it working. And in this case, and what NetBeans does is it's usually very helpful. So here I'm hovering on the red squiggly, and it says cannot find the symbol. Okay, when you can't find a symbol, there are two ways to address that. One is you can kind of click on the light bulb to the right that also has a little red thing, and it gives you various options. So here we want to import this CS2173 shape thing. We'll talk about what import is. It's probably one of the worst named things in Java because it actually doesn't import anything, but that's sort of another harangue. Okay, so here I'm declaring the variable to be a shape, and now I'm instantiating it. Okay, and now I can draw it. And here's where an array. So let's just see if that's working. Okay, so shape draw, shape erase. What did that do? That called these methods here. Right now, however, I'm going to make it a triangle. Again, it can't find triangle. Here's another way to do the import. You can fix all the imports with, if I just right click anywhere in the editor, and I go down to fix imports, and it will fix all the imports that it can. Okay, so here's my shape triangle. And now when I invoke, see now, because this is now an instance of triangle, when I run that, you see, I see triangle draw, not shape draw. However, if I do erase again, I get a shape erase. In other words, see, here's what happened. So here's what the Java virtual machine does when it runs. Here, when it looks for draw, it goes, okay, what is a my shape? What is this thing? Well, in this here, it's a triangle. So it goes to the triangle class and says, do you have a draw method? Yes. Invoke it. Done. Here, I invoke the erase method. Okay, what is my shape? Again, here in this context, my shape is a triangle. It goes to triangle and says, do you have an erase method? And the answer is no, I don't have an erase method. And so it will say, well, I see that you extend shape. Maybe shape has one. Let's look there. So it looks in shape and says, found the erase method, I will invoke it. And you see that is the shape erase method that gets invoked. Okay, finally. Okay, so at this point you say, okay, I know at this point that my shape is a triangle. All right, and triangles know how to flip, but it can't find the symbol. Why is that? It's right there. Because shape, the my shape variable, was defined to be a shape class. And so to decide which methods it's going to allow to invoke, it will use whatever methods are in the shape class exclusively. So this is the compiler. So even though I know that this object has this, it could have been a circle or just a regular old shape, which don't have the flip methods. So the compiler says, nah, not going to happen.
So what if you want to keep this triangle? Like you've made the perfect triangle, you love your triangle, but you first defined it, you first instantiated it as my shape.
Right.
Is it to start over, or is there a way to like change that?
Yes, there is. Yes. And the way to do that is something called a cast. And here's how I do that. In other words, this is what I want. Okay, so what I do is I do a cast. What I'm saying now is I'm overriding what we've done. I'm saying I know that this thing is going to, at this point, it can be a triangle. So I'm going to coerce it. I'm going to force it to be a triangle. And now I can invoke the flip method. Okay, so this isn't something that you're responsible for yet. Okay, so but since you asked, this is how you do it. In other words, and it's dangerous. It's dangerous because what if I did it up here? Okay, the compiler lets me do that. And it lets me do that because a triangle, in fact, is a subclass of shape. So this stands a fighting chance of working. It may work. So the compiler says, hey, you're the boss. But this is going to be an error. And it's going to be the worst error. There are two types of errors in a compiled language. There are compile time language errors, which don't let you, like this is a compile time error, and it won't let you run the program. Those are the best, believe it or not. What's a compile error is always better than a runtime error, which is the second kind. And this is going to be a runtime error. Why? Because even though my shape could be a triangle, it isn't. It's actually just a regular old shape. And so when I go to run this, I get an error. It says shape cannot be cast to a triangle. Why? Because I have an instance of shape and I'm trying to cast it to a triangle. So this does not work. That's why this is a dangerous thing. This is something that you can do every now and then. It's something that is necessary. Again, if you're totally in love with your triangle, as you said, there are cases where it is useful. So it is possible, but just remember that it's impossible. That it's possible, but don't do it. Okay, so all right, so now we're ready to start. Any other question? Now this inheritance idea and what you can do with which objects and how they're defined is that's an important one. What's important about it is it will understanding that will help you understand errors that you may be getting, and it'll also help you kind of navigate through through your code just to kind of understand what's going on, because it can be a little confusing. And I understand completely how it can be jarring to go from a non-typed language that you're used to a strongly typed language like this. And again, strongly typed languages like Java, they're just totally anal retentive, because it's like where we tried to invoke the flip on a variable that was just defined to be a shape, even though, I mean, we saw that that should have worked, but the compiler says, no, there's a chance this won't work, so I'm not going to let you do that. So it's just much stricter in terms of, as a programmer, you have to be much, again, much more strict. But that's a good thing. When it comes to big programs, the stricter you are, the more chance there is of your program working the way you want it to. Okay, so oops, I wanted. Wait, why is it? The hell? I'm still, where the heck is? All right. All right, there we go. Kept giving me the wrong one. All right, okay, so I've already alluded to this. So the compiler versus the Java Virtual Machine, or JVM. Primitive types. Okay, well, I'm going to go through primitive types here and show you there are 8 primitive types. We're only going to use a few of them. And then arrays. You're used to the the concept of arrays. You've kind of dealt with that. Again, a very important idea of scope, which I'm going to be haranguing about a bit, mostly because that helps understand kind of, it helps make your program a little more robust, and it helps understand why sometimes you can't, the compiler can't find things. And then we've already kind of touched on this, but we're going to go back to, again, how do you define a class, what instance variables are, what instance methods are, in contrast to other things. Okay, so the idea, first of all, the difference between the compiler and the virtual machine. Again, this is something which only exists in compiled languages like Java, does not exist in interpreted languages like Python and JavaScript. Identify what the main primitive types that we'll use. You don't have to remember all the different ones. If you're taking a Java certification, they kind of ask you these nitpicky things about these weird primitive types, and it's a pain in the butt. Arrays, for loops, and identifying scope. Those are the key takeaways from this. So we've seen an example of this a little bit, but just to understand a bit what's under the hood. The compiler, the Java compiler, takes your source code and it compiles it into something called bytecodes. And this is an intermediate form. It's not directly executable, but what happens is the bytecodes are executed by the Java virtual machine. And this was groundbreaking when it came out, because a number of programming languages, specifically C and C++, claim to be platform independent. In other words, the program would run on every different operating system that you had. In practice, it didn't work for a variety of reasons. Really, Java was, if not the first, one of the first truly platform independent languages. Now that's something that we kind of take for granted. And the thing is that for an interpreted language, that's not such a big deal, because the source code is the source code and you read the source code and everything kind of runs. But for a compiled language, it was a big deal. Now here's the thing, the compiler checks the syntax and it will not allow execution unless that's correct. If you, I believe those of you who've had the refresher, I believe they taught that in Python. One of the things that I run into Python a lot is that in a large program, there will be a problem that doesn't occur until the program's been running for a while. So you have the program, it runs for a while, and all of a sudden it bombs out. Why does it bomb out? Well, because there was a silly fat finger somewhere, but it didn't find it until it actually executed that. That problem doesn't exist in a compiled language, because if there's a syntax error, the compiler simply, in NetBeans, it gives, that's that red squiggly. And when you get the red squiggly, it won't run. Okay, the Java virtual machine takes those bytecodes and it turns it into an executable program. These bytecodes are what's identical for all the different operating systems. And what's different is the Java virtual machine is operating system specific. So here, the main two operating systems that we have are Windows and Mac. Does anybody use Linux? Okay, so that's the third main operating system that exists these days. So, but Macs and Windows, everything we do here, you may have noticed that I'm a Mac guy. I also will use Windows if I'm forced to, but some of you have Windows, some of you have Macs. All of this is going to work exactly the same. Okay, so let's. All right, so here are the primitive types. There are 8 of them. They're int, double, long, Boolean, char, byte, short, and float. The ones in red, we will, for the most part, not deal with. At some point, we might look at chars, but that's maybe. The ones we will deal with are ints. We've already dealt with that. Okay, now double, we haven't seen what is a double? A double is a double precision floating point number. A long, we will sometimes deal with longs. And what is a long? A long is like an int, only longer. And finally, Boolean. We've seen an example of Boolean. These are the 4 primitive types that we will use. These 8 primitive types are what makes Java only a 99 and 44 100% pure object-oriented language. In other words, in a pure object-oriented language, these would not exist. These would all be objects. In a pure object-oriented language, and something that represents an integer would in fact be an object. Okay, but that's not the case here. Okay, so those are the 4 primitive types, and that's just 4 things to remember, so I expect you to remember those. Now here's the thing, notice that there are default values. Okay, where are default values set? They are set only for instance variables that we've seen, and they are only set for elements of an array. But local variables have to be explicitly initialized. Now, what's the difference between an instance variable and a local variable? We haven't really, we've kind of seen that a little bit, but you're not totally responsible for that yet. But just kind of keep this in the back of your mind. If you remember, when we were in the main method and we were kind of defining those my shapes were all local variables. And if you notice that when I just declared it, I was getting a warning. It says, hey, it may not be initialized. So those do not get automatically initialized. However, instance variables do. And from a stylistic point, though, it's important to understand that they are automatically initialized. It's equally important to know that they shouldn't be. You shouldn't rely on that. Okay, arrays, does anybody not seen and know what an array is? Okay, you all know what an array is. The main difference is that arrays in Java are again, much more rigid than what you may be used to. But they're declared pretty much kind of here's how they're declared with these angle brackets. So I can declare them as either as primitive. So here's an array of ints, array of doubles, or if you remember, we had a class called light. I could declare an array of lights as a class. We instantiate those in a special way. So here I have an array of ints. I'm going to call it X, and I instantiate it to have 5 elements. And once I do that, the array X can only have 5 elements, no more, no less. It always has exactly 5 elements. Here I've declared an array of lights to be 10 lights, 10 exactly. The array's size is fixed. Again, that's different than what you may be used to. You may be used to arrays where I can kind of put stuff in and take them out. Here I can assign different values, but I can't just sort of put stuff. If I have an array of size 5, I can't just put a 6th one in. That will be an error.
Sir, so there's no splicing or inserting into the ends of arrays, none of those tech
Nope.
commands?
No. If you do that, there are ways, you say, well, how do I do that? Well, that's something we'll cover later in the course. But arrays are strict, and that's a good thing. Okay. Okay. Finally, scope. This is a very important concept. What's important is that it will mitigate confusion if you just sort of just keep this one thing in mind. In Java, scope is defined by the curly braces. So everything inside curly braces exists inside those curly braces, and outside it, you can't reference anything inside them. Again, we're talking about variables here. So for example, even in just sort of plain old code, I can just sort of put curly braces around any block of code like this. But since the variable X is defined within these curly braces, this is an error because outside those curly braces, X does not exist. Here's the first application of this, and this is the most common uses is like a for loop. So if I want to write a for loop, and you all know what a for loop is, right? Does Java have does JavaScript have a for loop? I'm seeing...
Yes.
Sure it does.
Okay, so, but again, this is the preferred scope of an indexed array here. So look at this. So okay, notice that I've declared my index variable here. So and we'll cover for loops in more detail, but the idea now, this I has scope only within that for loop. Outside that for loop, this variable I does not exist. And what that does is that allows fewer unintended consequences. What people noticed was that if you defined the indexed variable in a loop like this, outside of the loop, and then later on in the program, you use the same variable and expect it to be something else. and that caused problems. So understand what that is. Okay, so just a final thing are just some conventions, and these are going to be they're conventions in Java, but these are going to be required because I'm kind of OCD that way. Okay, one convention that I've talked about and we've seen is that all classes must be in a named package. So far, we've put everything into a named package, CS2173 or CS2173.run. Those are 2 named packages. You can put a class outside of a named package, but that will not be allowed in this class, in this course. So if you do that, then that will be a ding. Another convention, the package names are lowercase. So, so CS 2173 package was C and the S were lowercase. The class names, and we've seen this, are camel case. What's camel? You know what camel case is, right? So, okay, so class names are camel case. Instance variable and method names are lower camel case. So class names start with an uppercase C or uppercase, start with an uppercase, but instance variables and method names start with a lowercase. And that's a convention. Is it a rule, a law of nature? Absolutely not. It is totally arbitrary. And every language has these arbitrary conventions. They are important because they are the part of the idiomatic way of writing in the language. So if you write in Java, you should follow the idioms of that language. If you write in another language, if you write in JavaScript, you should follow the idioms of JavaScript. If you write in Python, like in Python, they have completely different idioms. There, everything is lowercase and they don't use camel case, or they don't prefer camel case. They use underscores and everything lowercase. That's the convention there. If you're writing a Python program, you follow that convention. But since we're writing Java, you follow Java's convention. And again, these are the conventions that we will require. And convention means that you're allowed to do something else, but I'm not going to let you do that. Okay, so I apologize. I took 2 minutes from you. I went a little over. My apologies, but that's okay. Any last thoughts? Any questions, comments?
So this might be
Everything-
a course-related question, but
Sure.
as far as that quiz on Friday, I know you said it covered the reading. Will you also be pulling questions out of the slides?
If there's something that I've kind of harangued about, then I might do that.
Copy that, sir.
So think of something that I've ranted. If I rant about something, then that means I think it's important. If it's something I've said, so for example, I presented for loops, but I'm not going to ask you about for loops because we haven't really gone through what that's about. I have ranted about scope though, so scope is something I might ask you about. Does that clarify things for you?
Yes, sir.
And the readings, and the readings will be through, like in the lesson I've asked you to do a reading for the next day. So and somebody asked that I put the readings for the whole weekend, and I'll try to do more of that. And so I'll put up the readings for next week toward the end of this week. But you're only responsible for what I've asked you to read through tomorrow. In other words, so for class 4, there's a say read this part of the book, but I'm not gonna quiz you on that part because we haven't talked about it. Okay, does that clarify things? Okay, very good. Thank you for your indulgence, and I will see you tomorrow.